Alright, I'm Danny,
I'm Costa.
I'm Noah.
and today you will be learning about 1D motion. So there are a few components to 1D motion. The first component is velocity. So velocity is basically the speed at which you're going and the direction that you're going, which we will explain further later. Displacement, which is the overall change in position of something, which Noah will be talking about later. Acceleration is the changing of velocity over a period of time. We will also talk about that later with gravity. And gravity, which we will talk about right now, is the force of attraction of a body towards the center of the earth, which basically means that if at all times your body is being brought downward. Alright. So what do you guys think will happen if we put these balls onto the bucket with the shirt on it? What do you think will happen? Alright, yeah. Okay, that's wrong. No. Alright, so what we're going to do right now is we're going to put this here, and we're going to see that there's an indent in the shirt. There's obviously an indent in the shirt. This shows the force of gravity acting on the ball, bringing it downwards. Can you pass this around and take note of the mass of it? Alright, now we're going to do it with the tennis ball. What do you think is going to happen now? Alright. The same thing will happen, except the indent this time will be smaller because, as we know, the tennis ball has less mass than the baseball. Can you pass this around? Thank you. Feel the difference in the mass? That's the difference in the indent in the shirt. Alright, our next demo will be done by Costa, and it will also be on gravity.
So this demo is going to show acceleration due to gravity. So as you saw, by holding both balls, the baseball obviously felt heavier in your hand, and the tennis ball was lighter. So what do you think is going to happen if I drop them both at the same height and at the same time? You think the baseball is going to drop first? Well, you're wrong. So what did you guys observe? Right, they hit the ground at the same time. That's because every object on Earth has the same value of acceleration due to gravity. So if I dropped an elephant at the same height as this tennis ball, they would both hit the ground at the same time. So, what do you guys think is going to happen if I push one to the side and drop one straight down? You're wrong again. They're going to hit the ground at the same time. Again, this is because the acceleration due to gravity is still the same for both balls. Now we're going to talk a little bit about displacement and velocity.
Okay, so displacement is like a distance traveled by an object, but it's only its overall change in position. So if one car goes straight and the other car takes a diagonal, the same position, if they started at the same position and ended at the exact same position, they're traveling, or even though this one's traveling a much greater distance, their overall displacement is exactly the same.
That's it.
Alright, so we have an example with this. We will have the kids come up, we'll have a ruler set on the table, and we'll drive the cars around in different ways, and we'll ask them how far each one traveled displacement-wise on the thing. Alright, so for our last demo, we are showing you what the difference between velocity is. And we'll do that by showing a catching up problem. Alright, so there's two ways we're going to show this. First we're going to show it with cars, and then we're going to show it with carts. We don't have the carts right now, but the main thing that we're going to show the kids is we're going to say what would have to happen for this car, the back car, to pass the car that's red. What would have to happen? Obviously, the velocity of this car would have to be greater. We would show this by doing that, having this one go slower. Now, what would have to happen for the two cars to stay equal distance apart? They'd have to travel at the same velocity and move in the same direction. And finally, what would have to happen for the first car to create more distance between itself and the back car? Well, obviously, the front car would have to go faster for the back car, creating more distance between the two objects. So then we would show the kids and we'd have them put on carts and we would show the same thing, basically, just with them having the carts and actually being able to feel what it would feel like to have a greater velocity than at a slower velocity.
Right. We use the cards to show the different components like acceleration, displacement, velocity.
And then as a take home, we would
We have a take home of a paper airplane, and I'll just make it really quick for you guys. And each kid will get to make their own paper airplane to be brought home for them, and they'll be able to play with it. And this shows the velocity. You can show velocity with a paper airplane. You could show acceleration, gravity. Gravity is always brought down, so eventually the plane will always fall. And there's also displacement because the object always moves in a certain direction. Just keep going with this airplane real quick. Just give you an idea of what it will look like. And obviously we'll answer any questions that the kids have.
Yeah, it should take up one.
And we'll also include the kids more in the conversation, asking them questions. And I'm sure they'll all be excited to answer. And there you have it. A beautiful paper airplane.
And that's our demo. So thank you for watching. That was 1D Motion.